Welcome back to The Explainer. So today we're tackling a question that is quite literally on everyone's mind and skin. We're looking at the undeniable global reality that our Earth is getting hotter every single year. We're going to break down the science, the hard data, and the international game plan, relying on the latest intel straight from NASA, NOAA, the IPCC, and the UN. Let's get right into it.
But hey, before we dive into the hard science, let me ask you something. Have you noticed something strange about the summers lately? Because, I definitely have. Summers just feel hotter. The heat waves are way more intense, they drag on longer, and even places that are historically known for having cooler weather are suddenly getting hit with extreme, record-breaking temperatures. I want to validate that feeling for you right off the bat. It's not just your imagination playing tricks on you. This is a measurable, dramatic shift in our climate.
All right, here is our roadmap for today. First, we'll look at Earth's unprecedented heat wave. Then we'll explain the greenhouse effect, followed by the human fingerprint. After that, we'll track the global impacts, and finally, we'll lay out our blueprint for the future.
So, starting things off with Section 1, Earth's unprecedented heat wave.
Now, you might hear people say, well, the Earth's climate has always changed. And historically speaking, they're technically right. Just in the last 800,000 years, we've had 8 cycles of ice ages and warmer periods. But those natural cycles were mostly driven by tiny variations in Earth's orbit that changed how much solar energy we got. This current warming trend we've been seeing since the Industrial Revolution, it is an entirely different beast. According to NASA, this current warming is happening at a rate we literally haven't seen in the past 10,000 years. It's the sheer speed of this change that is absolutely unprecedented.
The hard data here is just striking. The planet's average surface temperature has jumped about 2 degrees Fahrenheit, or 1 degree Celsius, since the late 19th century. And honestly, even a rise of 1 to 2 degrees Celsius is enough to cause massive extreme weather changes globally. Plus, the timeline is heavily skewed toward the present. Most of that warming, it happened in just the past 40 years. 2016 and 2020 tied for the warmest years on record. And NOAA data shows that 2025 just finished as the third warmest year on record globally, with July 2025 coming in as the planet's third warmest month ever. So the trend isn't just continuing, it is rapidly accelerating.
Moving on to Section 2, the greenhouse effect explained.
The absolutely crucial point here is understanding this specific mechanic. Earth naturally has this protective layer of gases in the atmosphere. It's called the greenhouse effect, and it's actually a good thing. Gases like carbon dioxide and methane let sunlight enter, but trap some of the heat from escaping back into space. It acts exactly like a thick insulating blanket, keeping Earth warm enough for life. Without it, we'd be freezing. But because of human expansion, we're basically throwing thicker and thicker blankets onto the planet.
Now you might think all that extra trapped heat is just hanging out in the air, right? Because we feel it in the summer. But NASA's data reveals a staggering reality. 90% of all this trapped extra energy goes straight into our oceans. Only a tiny fraction is actually absorbed by the atmosphere and land. The oceans are acting like this massive global heat sponge. And while that's temporarily saving us from even hotter air temperatures, it's fundamentally altering the chemistry and the sheer volume of our seas.
Which brings us to Section 3, the human fingerprint.
Okay, I really want you to let this massive number sink in for a second. 250. Carbon dioxide from human activities is increasing about 250 times faster than it naturally did after the last ice age. That is wild. By burning fossil fuels, cars, trucks, factories, cutting down forests, and just our excess energy consumption, we are releasing huge amounts of greenhouse gases into the air. And rapid urbanization plays a huge role here too. Sprawling concrete, cement, and a lack of trees create what we call urban heat islands that trap even more warmth right where we live. This isn't some slow, natural orbital shift. This is a massive, sudden injection of heat-trapping gases directly driven by human industry.
And if there was literally any lingering doubt out there, this powerful quote from the UN's Intergovernmental Panel on Climate Change, the IPCC, clears it right up. They state, since systematic scientific assessments began in the 1970s, the influence of human activity on the warming of the climate system has evolved from theory to established fact. So the human connection is not a guess, it's an undeniable, impartial scientific reality backed up by decades of satellite data, ocean profiles, and ice core samples.
Let's look at the real-world fallout in Section 4, tracking the global impacts.
We so often talk about climate change purely as an environmental issue, but take a look at this number from NOAA.
$2.78 trillion. That is the financial cost of 396 extreme weather and climate disasters in the U.S. alone from 1980 up to late 2024. And we're only counting events where the damages reached at least $1 billion each. We're talking about massive infrastructure damage, agricultural failure, and totally devastated communities. The economic stakes here are just astronomical. And then, look at the poles. The Antarctic ice sheet has been losing 100 billion metric tons of ice every single year since 2003. When that much land ice melts, all that water flows directly into the ocean, and it's a huge contributor to rising global sea levels. 100 billion tons. It's a volume of ice that is honestly almost too massive for the human brain to fully comprehend. But our satellites track it with incredible precision.
These shifts are creating severe, cascading effects across all of Earth's systems. As you can see, sea levels rose about 8 inches in the last century, but the rate of rise in just the last 2 decades, it's nearly double that. Because the ocean is absorbing all that extra CO2 we talked about, ocean acidity has shot up by 30%, which is absolutely devastating for coral reefs and marine life. And our glaciers? They are retreating almost everywhere around the world, from the Alps to the Himalayas, right over to the Rockies and Alaska.
Ultimately, these massive planetary shifts manifest right in our backyards. Extreme events are multiplying. The whole baseline of what we consider normal weather is shifting. This leads to the dangerous heat waves, unpredictable weather patterns, severe forest fires, water shortages, and acute health risks like heat stroke that we're seeing in the news basically every single day now.
So, what do we do about it? Section 5, our blueprint for the future. To understand how the world is trying to fix this, you kind of need to understand the 2 main engines driving global climate action. On one side, we have the IPCC. They provide the physical science basis and neutral assessments. Basically, they tell us what is happening. On the other side is the UNFCCC, the United Nations Framework Convention on Climate Change. They drive the international policy, they host the massive global negotiations, and they oversee the Paris Agreement. So, in a nutshell, the scientists study the problem, and the policymakers use that exact science to negotiate the solutions.
Now, a huge part of those negotiations revolves around this term NDCs 3.0. Let's demystify this crucial bit of UN jargon, shall we? NDC stands for Nationally Determined Contributions. These are essentially the specific, formal promises that countries are making right now to reduce their fossil fuel use and adapt to climate impacts. And that 3.0 part? That refers to the next round of these promises submitted in 2025, which the UN demands must be way more progressive and ambitious than anything we've seen before.
So how does this actually play out in practice? Well, the UNFCCC has a clear 3-step procedure to halt the warming. Step 1 is the global stocktake, basically looking at the hard data to evaluate our current progress or, lack thereof. Step 2 is submitting those new, highly ambitious NDCs 3.0 we just talked about. And Step 3 is the actual implementation of global mitigation. That means transitioning away from fossil fuels, massively scaling up clean renewable energy like solar and wind, and doing sustainable city planning to cool down those urban heat islands. And the motivation for this transition is becoming incredibly clear. I absolutely love this quote from Simon Steele, the UN climate chief. He says, "Clean energy is the antidote to fossil fuel cost chaos." That hits the nail on the head, right? The transition to clean energy isn't just about saving the environment anymore, it's about stabilizing our global economy. It's about protecting everyday people from the massive price spikes and economic shocks that come from relying on outdated fossil fuels. The big takeaway here is that Earth is not getting hotter by accident. It is getting hotter as a direct result of our industrial choices. But that also means the future is still very much in our hands. With robust global cooperation pushing major policy shifts, combined with local, everyday actions like planting more trees, transitioning to renewable energy, saving electricity and water, we genuinely have the power to cool down the planet's future. The scientific evidence is absolutely undeniable. We know the mechanics, we see the data, and we are quite literally living through the impacts. But the final outcome, that is entirely up to us. So I'll leave you with this question to think about. What choices will we make today for the future of our planet? Thanks for joining me on this explainer. I really hope you walk away from this feeling not just informed, but totally empowered. See you next time.